Great Lakes water levels at the end of 2025 were below average for the first time in a decade. That sentence came from the United States Army Corps of Engineers in January of this year. 4 of the 5 lakes sitting under their long-term average at once, not a record low, not a crisis headline, just a number that had not appeared in the file for 10 years, published in a routine bulletin that almost nobody reads. 6 years earlier, those same lakes were setting record highs, tearing houses off shorelines and swallowing roads. Now the trend had reversed and kept going. And every drop of that water, from Superior all the way down, has to leave through one channel 35 miles long that ends at a cliff in western New York. That channel is the Niagara River. That cliff is Niagara Falls. So when officials looked at the numbers coming out of Lake Erie this year, the question was not really about the lake. The question was about what happens at the edge. Here is the part almost nobody watching that water knows. What you see going over Niagara Falls is not the river. It has not been the river since 1950. The amount of water that falls over that brink at any given hour is a decision made by a committee, enforced by an 18-gate concrete structure sitting just upstream, and written into a treaty older than most of the people reading this. Roughly half of the Niagara River never reaches the falls at all, and there is a specific number in that treaty set 76 years ago that has never been renegotiated, never been updated, and was written by people who assumed the water would always be there. I'm Simon, and this is the story of what is actually happening to Niagara Falls. Why the drop everyone is talking about is not the one that matters, and what a group of engineers found in 1969 when they shut the American Falls off completely and walked out onto the dry rock to look at it up close. Start with the number the Corps publishes every month, because that is where this begins. In June of this year, the mean surface level of Lake Erie stood at 572.34 feet. That put it 3 inches above its long-term average for June and 1 inch below where it sat in June of last year. By the end of July, the Corps had Lake Erie running 2 inches below the previous year's level while still sitting roughly 2 inches above its long-term July average. Those are not dramatic numbers. Nobody looking at 3 inches is picturing a dry cliff, but the direction is the thing. Lake Erie peaked at record highs in 2019 and 2020. It has been coming down since, unevenly, with reversals, and by the close of 2025, the whole system had crossed a line it had not crossed since the mid-2010s. The Corps' own 6-month outlook at the start of this year projected all 5 lakes to remain below their long-term averages through May. What is worth noticing is how the agency described it. Officials called the shift significant. Officials also said the drop was not outside the normal range. Both statements came out of the same office, in the same reporting cycle, and both are accurate. That is the nature of this system. It moves in cycles that run longer than a career, which means the people measuring it are almost never able to say with confidence whether they are watching a cycle or a trend. One Corps scientist put it plainly in January, saying they were still analyzing whether the current rate of change falls inside historical behavior or outside it. That is not evasion. That is what the data honestly supports. And it is precisely the gap that makes this story worth telling, because the falls themselves are governed by fixed thresholds. The lake moves in ranges. The rule does not move at all. To understand why that matters, you have to understand what this river actually is. The Great Lakes hold roughly 18% of the world's surface fresh water. Superior, Michigan, Huron, and Erie all drain in one direction, downhill, toward the same outlet. That outlet is the Niagara River, a 35-mile connecting channel between Lake Erie and Lake Ontario. It is not a river in the ordinary sense. It is a drain for a system that covers 250,000 square kilometers. Over that 35 miles, the water drops about 326 feet in elevation, and roughly half of that drop happens at a single escarpment of Silurian dolomite laid down in a shallow tropical sea more than 400 million years ago. The falls sit on that escarpment. Horseshoe Falls, on the Canadian side, carries the overwhelming majority of the flow across a curved brink about 2,200 feet wide. The American Falls, separated from it by Goat Island, carries roughly 10%. That 10% figure is going to matter enormously later, so hold on to it. Niagara Falls State Park recorded more than 9.5 million visits in 2024, making it one of the most visited parks in the United States. The river below the falls supplies drinking water to communities on both sides of an international border, and the water that does not go over the edge generates a significant portion of the electricity for both New York State and the province of Ontario. Scenery, water supply, and power all drawing on the same finite flow, all governed by the same set of rules. Now here is where the story stops being about geology and starts being about engineering. On average, roughly 200,000 cubic feet of water per second flows out of Lake Erie into the Niagara River. During peak daytime hours in tourist season, the amount that goes over the falls is 100,000 cubic feet per second, half. The other half is pulled out of the river above the falls, sent through tunnels and conduits, dropped through turbines miles downstream, and returned to the river below the gorge. That is not an accident of drought or a seasonal fluctuation. That is the design. The instrument that makes it possible sits about a mile above the horseshoe. It is called the International Control Dam, and it is a line of concrete piers with gates that can be raised and lowered to hold water back or release it. It does not stop the river. It manages it, moving flow between the scenic channel and the intakes feeding the power plants on each side of the border. When the gates change position, the falls change. Most visitors standing at the railing have no idea it is there. The legal authority behind it is a document signed on February 27th of 1950 and brought into force that October, known as the Niagara Treaty. Its opening language is worth sitting with because it is unusually direct for a diplomatic instrument. The two governments recognized what they called their primary obligation to preserve and enhance the scenic beauty of Niagara Falls and the river. Everything else in the agreement is subordinate to that sentence. And then, immediately underneath that stated obligation, the treaty sets the actual numbers. The combined flow over the American and Horseshoe Falls cannot fall below 100,000 cubic feet per second between 8 in the morning and 10 at night from April 1st through September 15th, and between 8 in the morning and 8 in the evening from September 16th through October 31st. At every other hour of every other day of the year, the minimum is 50,000 cubic feet per second, half of the daytime figure, a quarter of the river. Read that again, and what it describes becomes clear. From November through March, and every night after the last tour boat docks, Niagara Falls runs at a quarter strength, not because the water is gone, because the tourists are. The treaty explicitly permits all water in excess of those minimums, after allowances for navigation and domestic use, to be diverted for power. The surplus is split evenly between the two countries. What the world photographs as an unstoppable force of nature is, for a substantial portion of every calendar year, a scheduled release timed to business hours. None of this was hidden. It was debated publicly, signed publicly, and administered ever since by the International Niagara Board of Control, whose responsibilities include verifying that flows meet treaty requirements, investigating and reporting on any violations, and inspecting the power plants to confirm the diversion figures are accurate. There is an entire oversight apparatus built around one question: is enough water still going over the edge to satisfy the agreement? The reason that apparatus exists is that the alternative had already been demonstrated. Diversion for power on the Niagara began in the late 19th century with small mills, expanded rapidly after the turn of the century, and by the 1909 Boundary Waters Treaty, the two governments were already writing limits to keep the river navigable and the falls presentable. After the Second World War, electricity demand climbed steeply, diversions increased, and the visible flow over the falls dropped far enough that it started to generate public complaint. The 1950 treaty was the response. The bargain it struck is the bargain still in effect today: a guaranteed minimum spectacle in exchange for unlimited claim on the remainder. Then came 1956, and a warning that almost nobody outside the region remembers. The Sholkop Power Station, built into the gorge wall on the American side, partially collapsed. Rock gave way behind it. The station was destroyed. New York's response was to build something bigger and further from the cliff, and in 1961, the Robert Moses Niagara Power Plant came online at Lewiston, 4.5 miles downstream, 13 generators, an installed capacity of 2,525 megawatts. Combined with the adjacent Lewiston Pump Generating Plant, a net dependable capability of 2,675 megawatts, and an average annual net generation of roughly 15.9 million megawatt-hours across the decade ending in 2023. On the Canadian bank, the Sir Adam Beck stations, the first of which began producing power in 1922, together deliver up to 1,962 megawatts. Add it together and you have close to 5 gigawatts of generating capacity built on both sides of one river, all of it dependent on the same flow, all of it operating in the space above a treaty minimum that was set in 1950 and has not moved since. That is the machine. Now here is the part of the story that changes how you read everything that came before it. For 12,000 years, Niagara Falls had been moving. Water pouring over the Lockport Dolomite caprock undercuts the softer Rochester shale beneath it. The shale erodes, the unsupported caprock eventually breaks off, and the entire brink retreats a little further upstream. That process carved the Niagara Gorge, roughly 7 miles of it, working backward from near present-day Lewiston to where the falls stand now. Historical estimates put the retreat rate somewhere in the range of 3 feet per year, with some accounts running as high as 4.5. Since the diversions, the falls have effectively stopped moving. Current estimates put erosion at around 1 foot per year, and for the American Falls specifically, some assessments put it at 3 to 4 inches per decade. Not per year, per decade. Take enough water away from a waterfall, and it loses the energy required to destroy itself. Industry defenders made exactly that argument at the time, and they were not wrong. The diversion that reduced the spectacle also preserved it. A falls retreating at 3 feet a year is a falls that will eventually saw its way back to Lake Erie and drain the whole system. Slowing that down was, by any reasonable measure, a good outcome, but it produced a second effect that took decades to surface. And in the summer of 1969, engineers went out and looked at it directly. If you are finding this as strange as I did when I first started reading the treaty documents, subscribe before we go further, because what comes next is the part that stayed with me longest. On June 9, 1969, under the direction of the Army Corps of Engineers Buffalo District, more than 1,000 truckloads of rock and earth began going into the upper river in the channel between Goat Island and the New York mainland. Roughly 28,000 tons of material built into a cofferdam about 600 feet across. On June 12th, the American Falls stopped. It is worth pausing on the fact that this was possible at all. It was possible because the American Falls carries about 10% of the flow. Divert that 10% into the horseshoe, and one of the most famous waterfalls on Earth simply switches off. The engineering was not exotic. It was rock, trucks, and arithmetic. What was underneath was not what anyone expected to find at a natural wonder. Bare shale, rubble, construction equipment, a scattering of debris and coins thrown by visitors over decades. One resident of Niagara Falls, New York, later told a reporter he remembered being disappointed, describing it as a desolate landscape of rock and tree limbs. During the work, the remains of 2 people were recovered from the riverbed. More than 100,000 people came to see it that first weekend anyway. The Corps had not shut it off for spectacle. They had shut it off to answer a question about rockfall. Large sections of the American Falls face had been breaking loose, and nobody could fully explain the mechanism. So with the water gone, geologists drilled core samples along the face. They ran colored dye into cracks to trace where it emerged. They installed instruments to measure stress and movement in the rock. What they concluded is the detail that reframes this entire story. The rockfalls were not being caused by the force of the water going over the top. They were being caused by water seeping in behind and beneath the Lockport Dolomite, eroding the soft Rochester shale underneath it from the inside until the caprock lost its support and let go. Which means the failure mechanism at the American Falls is not driven primarily by how much water goes over the brink. It is driven by water finding its way into the rock. Reducing the flow reduces surface erosion. It does not necessarily stop what is happening behind the face. The Corps also studied the talus, the enormous pile of broken rock at the base that had accumulated over the years and that many people considered an eyesore. The initial instinct was to remove it and restore a clean drop. The finding was the opposite. That rubble was propping up the cliff. Take it away, and the retreat rate would likely increase. In 1974, weighing that finding along with public comment and a price tag estimated at around $26 million, the International Joint Commission decided against removal. The rocks stayed. What the engineers did instead was reinforce. Bolts, cables, and anchors driven into the weakest sections of the face. Electronic rockslide sensors installed to watch for movement. On November 25, 1969, the cofferdam was breached and the water came back. So the American Falls that 9.5 million people photograph every year is a stabilized structure. It is bolted, it is monitored, it is supported at its base by a pile of rubble that engineers deliberately chose not to remove because removing it would have accelerated the collapse. And its erosion has slowed to inches per decade because roughly half the river is being routed around it. That is the object at the center of this story, not a wilderness, a managed asset held in a configuration that engineers selected, running on a water budget written in 1950. Which brings us to what happened when someone proposed doing it again. The two stone arch bridges carrying people from the mainland to Green Island and on to Goat Island were built in 1900 and 1901 in preparation for the Pan American Exposition. They are listed on the National Register of Historic Places. By 2004, they had deteriorated far enough that the state closed them and installed temporary structures alongside. Those temporary structures were never meant to be permanent either. In January of 2016, New York State Parks and the State Department of Transportation held a public hearing and released options for replacing them. Two of the three proposals involved building a cofferdam again and dewatering the American Falls for a period estimated at somewhere between 5 and 9 months. The stated reasoning was procedural rather than dramatic. The century-old bridges had to be demolished, which required a dry channel, and the piers and abutments for the replacements had to be constructed in the dry so the new foundations could be anchored properly to bedrock. The reaction was immediate and international. Headlines announced that Niagara Falls might be turned off. Canadian tourism operators noticed, publicly, that every visitor who came to see a dry American Falls would be standing on their side of the border to look at the working one. The state's own assessment acknowledged the double edge, noting that dewatering would likely draw crowds initially as a once-in-a-lifetime sight, but could hurt park attendance over time, particularly during summer. Local critics raised a question that has never been fully answered. The bridges were built in 1901 without shutting off the falls. They were worked on in 2004 without shutting off the falls. Bridges get built across moving water constantly. Why was this the option on the table? By 2022, state parks confirmed the dewatering idea had been scrapped. The department described a project in the range of $55 million to replace the historic pedestrian crossing, still in design, with officials describing intensive concrete coring of the existing bridges to inform the next design phase and simultaneous work to secure funding. So as of now, the bridges from 1901 are still standing. The temporary spans installed in 2004 are still carrying the load. The design is not final, the funding is not fully secured, and the plan that would have stopped one of the two great cataracts of North America for the better part of a year came close enough to happening that it made global news, then quietly stopped moving. Now widen the frame, because the reason all of this is being re-examined right now has nothing to do with bridges. The water budget those 1950 numbers assumed is changing in ways the treaty never contemplated. Satellite records of Great Lakes ice cover begin in 1973. Across that record, the average annual maximum ice extent exceeds 40%. In late February of 2024, it stood at roughly 1/10 of that average maximum. NOAA's Great Lakes Environmental Research Laboratory has measured annual maximum ice coverage declining by approximately 5% per decade. Mike McKay, director of the Great Lakes Institute for Environmental Research at the University of Windsor, has estimated ice cover down about 75% across the last half-century. Ice is not decoration on this system. Ice is a lid. When the lakes freeze, evaporation is suppressed. When they do not, warm surface water meets cold air, and the lakes give up moisture directly to the atmosphere. Researchers at NOAA have pointed out that much of the evaporation on the Great Lakes actually occurs while ice is forming, during the period in fall and early winter when the water is still relatively warm and Arctic air begins arriving. Shorten or weaken that ice season, and you change the rate at which the entire system loses water. The scale involved is difficult to hold in your head, so here is the comparison that makes it concrete. Researchers at the Great Lakes Integrated Sciences and Assessments Program have noted that losing roughly half an inch of water off the surface of the Great Lakes in a single day is about 20 times the volume that goes over Niagara Falls in that same day. Half an inch, 20 Niagaras. That is the arithmetic of a system this large, and it is why the number that governs the falls has almost nothing to do with the falls and everything to do with weather over 5 inland seas. And this is where the honest version of the story diverges from the alarming one, because the science does not point in one direction. Earlier generations of climate modeling projected substantial long-term declines in Great Lakes levels. More recent work has found that many of those earlier models were overestimating evaporation. A study led by climate modeler Pengfei Xu at Michigan Technological University, using a combined regional climate model and three-dimensional lake model, projected the opposite: increases by the 2040s of roughly 7.5 inches on Lake Superior, 11 inches on Lake Erie, and 17 inches on the Michigan Huron system relative to the 2010s, driven mainly by increased precipitation and runoff outpacing evaporation. The same work acknowledged wide uncertainty across individual model runs, with the range for Lake Erie spanning from a modest decline to a substantial rise. So the scientific literature currently supports a future in which the lakes are higher and a future in which they are lower, depending on which model run you read. Meanwhile, the observed record shows record highs in 2019 and 2020, a sustained decline since, and a system that closed 2025 below average for the first time in 10 years. Consider what that means for a treaty that specifies exactly 100,000 cubic feet per second and exactly 50,000 cubic feet per second at exactly specified hours on exactly specified dates. Those figures are not proportional. They are not indexed to the actual flow available. They are fixed numbers. In a wet decade, there is enormous surplus above them, and the power authorities capture all of it. In a dry decade, the surplus shrinks, and the treaty language is explicit that the scenic minimum takes precedence over generation. Power output at Niagara has already been reduced below capacity at times of low flow, specifically to keep the falls at treaty level, which means the pressure does not show up as a dry waterfall. It shows up as generation curtailment on two of the largest hydroelectric facilities in North America, quietly, without a headline, during exactly the periods when the lakes are running low. That is what a system designed to protect scenery looks like when the water tightens. The tourists never see the difference. The grid does. There was another reminder this year that the variable nobody controls is the weather. This past winter, Lake Erie and the Niagara River accumulated so much ice that removal of the ice boom, the floating barrier strung across the mouth of the river each winter to stop large flows from moving downstream, was delayed. Boat tour operators postponed the start of the 2026 season to the 1st of May. A system supposedly warming out of its ice had a winter cold enough to push the tourist calendar back by weeks. Both things are true at once. The long trend is down. Any individual year can do whatever it wants. That is exactly the condition under which fixed thresholds become brittle. So where does this leave the falls? The treaty from 1950 remains in force, unchanged, with the same two numbers written into it that were written 76 years ago. The International Niagara Board of Control continues verifying compliance. The control structure upstream continues moving water between the scenic channel and the intakes, more of it to the falls during business hours, more of it to the turbines at night. Around 5 gigawatts of generating capacity on two sides of a border continue drawing from the same river. The American Falls remains bolted, censored, and propped at its base by rock that engineers deliberately left in place. The bridges from 1901 remain standing, past their design life, with a replacement still in design and still not fully funded. And the Army Corps continues publishing monthly bulletins in which Lake Erie sits a few inches one way or the other, described in the same report as both significant and within the normal range. What has not happened is any public process to revisit those two numbers. No renegotiation, no indexing of the scenic minimum to actual available flow. No formal reassessment of whether a threshold set in the era of the Skullcope collapse still makes sense in a basin where the ice season has lost most of what it had and the models cannot agree on which direction the water is going. The people who wrote that treaty made an assumption so basic they never had to state it, that there would always be more water than the minimum required. For 76 years, that assumption has held. It has never once been tested at the low end. Niagara Falls is not going to run dry. That is not what the evidence shows, and I am not going to tell you it does. What the evidence shows is stranger and harder to look away from. The falls have already been reduced by half, on purpose, by agreement, for 3/4 of a century. The erosion that shaped them has been nearly switched off. The face is held together with bolts. The base is held up by rubble somebody decided not to move. The volume is set by a schedule. And the one document holding the whole arrangement together contains a number that nobody has questioned since 1950, protecting a natural wonder that has not been entirely natural since before most of us were born. So here is what I keep coming back to, and I want to know what you think. If the water going over Niagara Falls is already a number chosen by people rather than a fact of the river, and that number was chosen in a decade with a climate that no longer exists, then who is responsible for deciding what the falls should look like in 2050? The engineers who keep it standing? The two governments who split the surplus? Or the 9.5 million people a year who show up at the railing, hear the roar, and assume they are watching something nobody controls? Tell me in the comments. And if you want to know what happened the other times the falls stopped, including the winter the ice did it without anybody's permission, subscribe, because that story is coming next.